Hello, welcome to episode 28. We're going to try something a little different today, and we have moved over to RunKit from my typical Ramda REPL. We'll see how this works. Let me know what you think. But the cool thing about this is all completely runnable. It stores everything with in a Git repo, so you can clone and do all sorts of cool stuff. And thanks to Nate Taylor for bringing this one to my attention. So you see, we're doing a few different things. We're requiring Ramda, and we're going to require future. And that's because today, what we're going to talk about is doing parallel operations using applicatives. We've been talking about applicatives. Some of the stuff we've talked about is validation and a few other things. But one of the really neat things you can do with applicatives is to do concurrent parallel operations. So, episode 28, parallel operations with applicatives. So what are we going to do? So let's look and say we've got some sort of home page, and I'm stringifying all this, but let's assume it's some sort of a view renderer, whether that be React or anything else. But to create a home page, to return the HTML for the home page, we're going to require a user and an array of posts, and we can then output some HTML. So that's basically what we're doing right here. If you've seen any of the previous videos that I've been doing on applicatives, you know that lift is going to take this home page, when supplied with the function home page, lift is going to return us a function that, when given an f of a user and an f of an array of posts, will give us an f of an HTML. So basically, it says it's going to be a function that's now managed by adding these applicative functors together rather than just regular values. And so we have some examples of some futures, because that's what we're going to do here is futures rather than promises or anything, because futures are going to be pure and they're going to be lazy. So we can compose these things up, define what we want to happen when we say go, and we can define all of these different things up, how the interactions happen, and then finally say go only at our application boundary so we know where these side effects are happening. So that's why we're going to create a user f, which is just a future of, and rather than actually issuing a web request, which probably would actually work now in RunKit, I'll have to validate that, but in this case, we're just going to return a future of. So basically, it'll be a future of either an error or a user, and then the posts that we're going to get, it's going to be a future of an error or an array of posts. You can see that we've got a future in this user and this posts array. Looks like perhaps could be thrown right into this lifted function. And indeed, that's what we're going to do. So we call the lifted function with a user f and posts f, and what that returns is actually another future that contains the result of having both of those. So that returns a future of this home page. Basically, it's a future of HTML, which we would see here if we substituted future for each of these f's, which actually don't even have to squint too hard because it starts with the same letter. But that would return a future of HTML. Now with the future, to actually run it, which we would only want to really do at our application boundary, we call fork, and that will run the future. And then another benefit of using that future when we're calling fork is when we call fork, we have to explicitly define an error case and a success case. So rather than a promise, where if we're using a promise, nothing forces us to put in a catch block or chain through the catch. Nothing forces us to do that. In this case, because of the way that the future spec was implemented, thanks to the Fantasyland spec, we have to provide our error case, which is right here. It's the first function that we pass to fork. The second function that we pass is our success case. And basically, I'm just going to set those to some windowed result. This is going to happen at our application boundary anyway, so that we see our result. So if we run this, what do we get back? Well, it's pretty cool, actually. If we look at the full text, we get our JSX. And thanks to me doing some JSON stringifying here, we get exactly what we would expect. So there we go. That's episode 28. This is all dealing with all parallel with applicatives. I have a feeling that episode 29, we're going to combine some stuff with monads so that we can show that some of it's sequential. Claire's taking us out there, so we'll let her do it. Hope you all enjoyed it, and we'll see you next time.